So in yesterday's class, we have seen, is that right? In today's class, what we'll be doing is that we'll be talking about here. We have found that the acceleration due to gravity and gravitational field intensity on the surface of the Earth, they are same, right? So we'll try to see how is this changing. Okay, how is this value of acceleration due to gravity changing on the surface of the Earth? Is that okay?
Yes, sir.
That's for the heading, yes. Variation in value of G. Sorry, not capital G. Capital G will never change. Variation in value of small g. Acceleration due to gravity. First, let's talk about variation due to height. Variation in value of g due to height. Due to height. Clear? So let's assume that if this is Earth of mass capital M, Earth of mass capital M, and let's say this is some small mass, here M. Now the radius of Earth is r. The radius of Earth itself is r. Now let's say that the height, additional height from the surface of Earth is h. Now, definitely this will experience some acceleration due to gravity. Is that right? You see, actually, this was supposed to be experiencing a force Fg. This was supposed to be experiencing a force of minus Fg. Clear? So, because of this, this will be experiencing some acceleration g downward. So, what we can say about the value of g? G bar is equal to Fg by small m. Is that right? That will be how much? G capital M small m by r square, or we can say that is equal to E bar also. Clear? That we can directly write as Gm by r square in radially inward direction. Radially inward direction. That is what is happening to the magnitude of G. G is equal to G capital M by what's the value of small r? Here the value of small r is capital R.
Capital R plus H.
Capital R plus H whole square. Clear? Now here as H is changing, is the value of G changing? Yes, definitely it is changing.
Yes, sir.
Right? So this is how the acceleration due to gravity g is going to change from the surface of the earth. Here from the surface of the earth, let's say that means if you want to talk the variation value of g from the, if you want to talk about the radius r, here from the radius r, so till capital R it will be gm by r. Clear? This is g is equal to gm by r square. Clear? But after that it is r plus r. It is inversely proportional to r square, right? So it is going to decrease hyperbolically. It is going to decrease hyperbolically. Inversely proportional to r square. It is going to decrease hyperbolically. This is the true variation. Now here what we generally do is that we talk about some approximation. The approximation is that if h is much less than r, that means if the height at which the ball is present on the surface of the earth, if at all it is very small, maybe 100 meters or some kilometers, because we know that the value of r, the value of radius of earth is somewhere around, the average radius is 6400 kilometer, right? So compared to the 6400 kilometer, if you consider any small height, that will be h is much less than r. So what we can say over here is that in such situation, this will be gm by, let's take r square common, this will be 1 plus h by r whole square. Now here we know a binomial approximation. What does it say is that if If x is much less than 1, if x is much less than 1, clear, this implies 1 plus x whole power n, 1 plus x whole power n can be written as 1 plus nx. Here, if at all this is plus or minus is there, then based on that, this will be plus or minus nx. Is that right? So based on this logic, what we can do is that here, let's take this to the numerator. GH will be equal to GM by R square times 1 plus h by r whole power minus 2. As per this binomial approximation, I can say g by r square into 1 minus 1 plus of minus 2 times h by r. So this will be gm by r square into 1 minus of 2h by r.
So we can put
Okay.
Gm by R square equal to G on ground.
Yeah, gm by r square is equal to g on ground. So let's call this as g or g naught. Let's put it as g naught. That means the the regular value of g naught. Here, what we'll do is that where g naught is equal to gm by r square is the acceleration due to gravity on surface of Earth. Acceleration due to gravity. Did you get the logic? But this is only for h much less than r. You will not believe me, but in my school days, in my physics textbook, there was something written, and actually I believed it. In fact, all of us believed it. So what was mentioned was that here I'll tell you that at h is equal to r by 2, it was said that gh is equal to g naught into 1 minus of r r 2 into r by 2 by r. So this will be r by r1, so it will be 0. So you feel weightless. Tell me, is it correct?
Sir, no, sir.
Why?
R by 2 is not like
It is
substantially lesser than.
not substantial.
G for much less than R, we can use this formula.
Yes, this is for much less
This
than r
is
only.
pretty much a significant value compared to
Yes,
the radius of the Earth. So we have to use the first one.
3,200, so that's very significant.
Correct, very good.
So can you explain that graph? Because I just joined late a little bit. Just that graph.
It is inversely proportional to r square, right? As r tends to infinity, gh will tend to 0. Gm by r square graph I have plotted. In fact, if you
Okay.
wanted this, I have to plot it negative in a negative side, but I have just plotted the magnitude. Put r is equal to 0, this value will become infinity. Put r is equal to infinity, the value will become 0. But we know how is it is changing from a certain distance, right? What is happening inside it, we are not aware. That's the reason why we did not plot it.
Okay.
Did you get it? R is equal to 0. This was supposed to tend to infinity, but because we
Okay.
didn't
But
we
we
didn't
don't know
know
what is happening.
what
We don't know what is happening
inside
with
there. That's the reason why we did not plot.
okay. Can you zoom out, sir?
Now those are done copying. Can you try a simple question? The height at which g will be equal to g naught by 2. The height at which the value of g will fall to half. Is it done copying?
1 minute, sir.
There is h is equal to r by 4. Sir? Sir?
By 4, I don't think. Look here. If take an example.
You
If
said gh is
GH
equal to
is
g
equal
naught
to
by 2, no?
if GH is equal to G naught by 2, this implies what do you know about the value of GH? This is G naught into uh, what's the original relation? G naught by R plus H. G naught by R square into R plus H whole square, right? Can we write it this way? No, Gm by R square. You see, this is Gm by R plus H whole square, right? So what I can do is that I'll write it as Gm by R square into R plus H whole square. So we can say that this will be Gm by R square in like let's divide the denominator by R square and multiply the numerator by R square. So this will be G naught into R square by R plus H whole square. Do you agree with this?
Yeah.
So this will be G naught by 2. G naught get cancelled. This is 2 R square is equal to R plus H whole square. So let this will be root 2 R is equal to R plus H. Is that right? Root 2 R is equal to R plus H. So H will be equal to root 2 minus 1 into R. Is that correct?
So could you once show the graph? Sir, so the question you gave right now, we can't use GH is equal to G naught into 1 minus 2 H by R because we can't determine whether it's a very
Whether it's very
small.
significant or not.
Yes.
Yes, sir.
It's
So
always
we have
better.
to use the first.
I would always appreciate to go with this relation only.
Okay, sir. Okay.
Now, because we do not know what is happening inside F, so let's try to find it. Variation in value of G.
Sir, can you slightly go up?
Not able to hear you clearly, Karthik. Let's say if this is the surface of the earth. Inside, what happened is that you have filled. You're considering the mass.
So he's asking you to go slightly up. He has to note the example change.
Okay.
So at depth it will be r minus h whole square.
It will be R.
Minus h whole square. I mean instead of r plus h whole square in the original formula.
I mean, do you mean to say that that should be under when you take the minus, this could have been minus root 2 plus R, and this would
I'm
be
not talking about this example. I'm talking about the variation in value of g due to depth.
due to depth. You feel?
I think it will be r minus h whole square. I
R
mean in the
minus.
original formula.
Oh. Let's see.
So he's done. He wants you to explain the example.
Okay.
Yeah,
The thing is,
Karthik.
uh, you see, at what height G will be equal to GH by 2. Understood. That means weight will become half. So for that, we know that the value, how will the value of G will change as per height? So that is G naught R square by R plus H whole square is equal to G naught by 2. So from this, we have written H in terms of R. That's it. So what I advise you to do is that most of the cases, go with this original formula of H. Understood? When you're not certain about the height. If you are very sure that the height is very less, then you go with this relation, this one. But
So
that is
even
not
if the
always.
height is very less, the first formula will hold true, right?
Yes, because this is applicable only for one particular case. That is, if H is much less than R, that's a clause over here. So this is star
Okay,
mark.
sir.
It has to be applied with condition. If you're not sure, then go with the original formula.
Sir, but if h is much less than r, then like why can't we consider the acceleration of gravity to be unchanged? Because I don't think there will be much change, right?
That's why in projectile motion we have assumed the gravity to be constant.
Okay,
Remember?
so h is very much less than r, then we can use the same value
Yes,
of g, that is
you
9
can
point.
take G as constant.
Okay.
Now assume a situation that this is the surface of the earth. Okay, this is the radius R. From the radius R, what you have done is that you have dig a pit. Here you have dig a pit, and there you have placed a block of mass m at a depth d from the surface. Clear? Total is R. From that, that means this is at a height of how much? R minus d. Is that right?
Yes, sir.
R minus d.
Yes. So,
So now look here. The thing is that we have something called Snell's law. Okay, not Snell's law, Shell's law. From Shell's theorem. Okay, this Shell's theorem, uh, you do not have proof for this. Okay, we just use it in our syllabus. Understood. Now this Shell's theorem says that only the mass inside this part can influence the mass inside this part can influence the or exert force or exert, like it will influence the mass present over here. So anything outside this shell cannot influence it. Did you get the logic? Only the blue part can influence the mass over here, mass m placed over here. The
what do you
entire
mean influence?
what is it?
What do you mean by influence, sir?
It cannot exert force on it.
Okay, so the remaining part which has the width d would not exert any gravitational
Yeah,
force.
this is
Yes,
Only
that's
the
what
blue
the
part will.
Shell theorem says.
Okay.
Understood the logic?
but there is no
Here,
proof for it.
Yeah, we
Yeah,
don't
we
have.
don't talk about proof, right? Even the proof is not that interesting. Understood? Once gone
Okay,
through the
okay.
proof, it is not that interesting. Okay, but in electrostatics, you'll come to know, because as of now we are not solving for the value of fields and all those things. We may not be in a position to check the answer, but when we go into electrostatics, there we'll check it. Understood? That is not really influencing. So from Shell's theorem, let's say if acceleration at this point, okay, acceleration at this point will be equal to how much? The force acting on this. Let's say this is Fg. Hmm. I'll erase this one here. This is d, so this distance is how much? R minus d. From the center, this distance is R minus d. So let's say this, both of them are experiencing some force Fg, and this is minus Fg bar, or we can say this is simply Fg. Magnitude wise, it is Fg. Now, the thing is that total mass of the Earth is m, but now is entire mass influencing this Fg? No, right?
No,
Is
sir.
it
Yes,
Only
sir.
electrostatics?
part which is
Fg
the depth
is
only D.
is equal to
That
G. Now instead of M, we use M dash, small m, by R minus by R square. Is that right?
yes, sir.
So that should be the value of G is equal to how much? G M Fg
M
by,
dash by R square.
yeah. So that will be Fg by M. So that will be equal to G M dash by R square. Here R is nothing but R minus D. So we need to talk about, or else as of now leave it as a small r. Then we'll calculate what is the value of M dash. Now look here, the density of Earth is constant, right? Since density of Earth is constant, that
Sir,
this
G
implies,
general by R square, sir.
yeah, that is
Yes, sir.
R
R
square.
square.
Density of Earth is constant. Rho is equal to total mass is m by volume is 4 by 3 pi capital R cube. Clear? Now if I want the small mass m dash, can I write as density into volume 4 by 3 pi small r cube? Yes, that will be density will be m by 4 by 3 pi capital R cube times 4 by 3 pi small r cube. 4 pi by 3, 4 pi by 3 gets cancelled. So this implies m dash is equal to m by, uh, yeah, so m times small r cube by capital R cube. Is that right? If we substitute this value over here, this will be g m time by r cube into, here that was supposed to be small r cube by r square. You can say that the value of g is equal to how much? Gm by r square into small r by capital R. We know that gm by r square is nothing but acceleration due to gravity on the surface of the Earth. Is that right? So this is small r by capital R. This is variation due to small r. So that is, but what do you know about small r? Small r is nothing but the separation between them. Here the separation between them is small r, but that is
R minus D.
r minus d. So g naught into capital R minus d by capital R. So this is g naught into 1 minus of d by r. So this is how you write for the expression of value of g. So I can write this as gd. Here finally I'll say this as gd. Variation in acceleration due to gravity due to depth. I'll say that as g naught into 1 minus of d by r. Did you get it? Now, if you want to plot this into the original diagram, so what is happening? Like if you plot it, if you are interested in plotting a curve, you see, this was supposed to be r. Clear? This was supposed to be r. In fact, if you plot it in terms of this r directly, because we know that g is equal to g naught r by r, so this will be g is equal to, yeah, this is the value of g if you're plotting. Put r is equal to 0. Put r is equal to 0. So what will happen? This will be g naught into 0 by 0. That will become 0. Is that right? Put r is equal to 1. That value will be how much? G naught. put r is equal to capital R, the value will be how much? G naught is equal to Gm by R square. That means in between them, how is it changing? It is proportional to R, right? Clear? So that is for
Yes.
R less than R, for R less than or equal to capital R, G naught is equal to G small r by capital R. So G is equal to G naught small r by capital R. G is equal to G naught small r by capital R. This is how it is changing, like a inclined line. But for if R is greater than or equal to small r, if R is greater than capital R, then how is it changing? G is equal to G naught into capital R square by small r square. Is that right? G is equal to G naught into capital R square by small r square. So here this is G naught is proportional to R. Here G naught is inverse, sorry, not G. G is inverse. Here G is proportional to R over here. Here G is inversely proportional to R square. So at infinity it will become 0. Did you get the logic?
So could you explain this graph again, sir?
Yes, sir.
Here instead of plotting in terms of height and depth, I am plotting in terms of distance R. We know that here if R, this is actually, I think this has created a lot of confusion among you. Here, this is Gm by R square. That means Gm by capital R square is how much? Look here. G is equal to Gm by R square, right? Here G is equal to Gm by R square we have got. So let's multiply by R square, divided this by R square. So this is Gm by
G
R
naught
square.
into R square by.
Yeah, into capital R square by small r square. So this is G naught into capital R square by small r square. This is how the value of G is changing, provided if R is greater than capital R. Is that right? For R greater than or equal to capital R, this is how the value of G is changing. For R less than or equal to R, how did the value of G change? Here we have written that if R is less than or equal to small r, we know that G is equal to G naught into small r by capital R. Did you get the logic? So I've used these two. I did not write it in terms of height and depth. I plotted how it is changing from the center of the earth. At the center of the earth, you feel weightless. As you're moving away, it will increase linearly. At the surface of the earth, you experience maximum weight, and as you're moving away, it will decrease.
Decrease.
It will decrease
Sir,
hyperbolically.
I have a doubt. When okay, small r is equal to capital R, then what will be? Because both the conditions it's satisfying
Here,
and
if
both are
smaller is equal to capital, as per this condition, this capital get cancelled, you get the value of G naught. Now, as per this condition, if capital R is equal to small r, again r square by r square, that will be again G naught. So both conditions satisfy the same value. That's the reason why I've shown that both of them are agreeing on the value of G naught at a distance r from the
okay.
center of the earth. Is it done?
No, sir.
Sir, in plotting the graph, how did you determine the other formula, sir? G equal to G naught into R, capital R squared by small r square?
Here I've written it. From this expression. Did you get it?
Yes, sir, I've got it. So could you scroll down to the graph?
Is it done?
1 minute, sir. Done, sir.
Is if you wanted this plot the same thing as a function of h, clear, if you wanted to plot the same curve as a function of h, how this would have been done? Understood? How this would have been done? Now the thing is, we know that g is equal to g naught into r square by r plus h whole square. You see, plotting as a function of r is different, plotting as a function of h is different, because in this case, r we have taken it as r plus h, right? So if you try to simply plot the value of g as a function of h, then put a h is equal to 0. At h is equal to 0, its value will be r naught. As h tends to infinity, its value will become 0. So this is how the value of g will change as a function of h. That means whatever this part, constant part r is there, that is missing. Is that okay? Now similarly,
Yes, so it varies hyperbolically, sir, or
yes,
is it
that is
different?
varying hyperbolically. This is inversely proportional
Okay,
to
sir.
h square. Clear? Kind of, because it's r plus h whole square. So the variation is same. Understood? The only thing is that here r minus h is there. So this is, yeah, must become 0. So this is inversely proportional to h square. Now, next thing, if you want to plot, because we know that here, what's the value of r? R is equal to capital R minus d, right? Are we plotting in this region? This is due to height, right? Yeah. If you want to, okay, let's plot it here. Yeah. If r is, because over here, R is equal to how much? R is equal to Kepler minus D. Is that right?
Yes,
Kepler
sir.
minus D. Now, if you try to plot the value of D as a function of G, put D is equal to 0. What will be the value?
G not only.
Capital R.
Because it will be on the surface of the earth. Clear? D is equal to 0, you will be on
Yes,
the
sir.
surface of the earth, your value will be G naught. And if you put D is equal to R, in fact, that's the maximum value possible. That D is equal to R, that's the maximum value possible. So at that instant, what is happening? This variation is 0, right?
Yes, sir. 0.
This variation is 0. So from this, what you can say that too, it is decreasing linearly. So this is the graph. Do you agree?
How is it decreasing linearly?
Because the value of G is increasing linearly from 0 to R. That means from R to 0, it is decreasing linearly, right?
Yes.
Magnitude wise, you see, G is equal to G naught into Kepler minus D. That will be 1 minus D by R. So let's put this is G is equal to G naught minus G naught D by R. Clear? G naught D by R. So this is G. Uh, yeah, how is this of the form? This is of the form. This will be Y is equal to plus C minus MX.
Yes, okay, negative slope
Yes.
and
Yes,
positive y
negative
intercept.
slope with a positive constant, Y constant. Is that okay?
So could you once show the G versus H? Yes, just a minute.
Actually, here I'm plotting only the magnitudes. Here I'm plotting only the magnitudes. Now, had it was asked the value of E as a function of R, understood? The gravitational field as a function of R, then this would have been a slightly different curve. Understood? This should have been a slightly different curve. How means? We know that since G is equal to Gm, E is equal to Gm by R square, right? You see, this is a slightly different story, but still, let me plot it here itself. I told you, right? This negative sign is going to make a difference. Is confused, create a confusion because we know that E is equal to Gm by R square with the minus R cap direction. If you try to plot the electric field, understood? The gravitational field outside the Earth's surface as a function of R. The thing is that if this is R, that means increasing value of R. Put R is equal to Kepler. Okay, till here on the surface. Okay, on the surface. Here it will be how much? Minus Gm by R square. Till here it is going to be negative because it is radially inward. Now, as you move away, it will become 0. Understood the logic? So this was supposed to be a negative curve. The value of E, because it was negative. Negative indicate that it was attractive. Understood? Similarly, here, if you wanted to plot this E as a function of R, understood? If you wanted this to plot this overall E as a function of R, then that would have been very weird. Don't you feel that this negative sign is irritating?
So that's why we consider only the magnitudes when plotting graphs.
Yes, correct. So till here it will be a straight line. After that, it will be varying. It's good, man. This is I hope you understood it. The issue. This will
Yes,
be
sir.
minus Gm by R square. That's the reason why I'm avoiding it. Because you see, in so clear-cut result itself, this negative sign is creating so much problem. If you remember in the derivation also, it created a problem because it was attractive force, only attractive force. So that's the reason why we are not doing it. Because if you try to calculate the gravitation field and potential for the sphere, hollow sphere, solid sphere, line charge, all those things, they're going to definitely make trouble us. Understood? So that's why we'll learn in electrostatics, and in electrostatics it's much more simpler. Understood? It will not be this irritating.
So do you want us to draw these graphs drawn in blue, or
Yes, yes, I want you to draw it.
so could you label each graph, the blue graphs, like what it is for, which versus what?
This was just for H. Now this is R and H, depth as well as H, inside as well as outside. Same. You see, it's a inverted version of G,
Okay, sir. Yes.
magnitude. Again, if you put magnitude of E, then you'll get the same value of G only.
Because magnitude of
You
E
have to
will
plot
be
the original value. In
G
fact,
only.
if you have asked to plot the value of G also, then also G bar. You see, we have plotted for the magnitude of G. Even if it is asked to plot G bar, then the
Then we'll
blue
get the
graphs are the
second.
correct one. Because there we have to indicate the direction, and direction we always assume anything away towards the radius is positive, and anything which is radially inward is negative.
So we should draw that graph also beside the blue one.
Beside the, yeah, everything should be drawn. Are you done copying?
No, sir.
So could you go to the previous one, as in the previous one in blue, the previous graph?
Here I've
For a
just
second.
plotted the half portion of it. That's it.
Yeah, okay, okay.
Because that was only due to height.
Okay, so that's not necessary. Suppose this is better, sir.
Hmm. This is a
Okay.
complete graph.
Yeah, yeah, yeah.
So in the previous graph, we didn't draw the first part of the graph where G is
Where the
varying
object is
linearly with R.
inside the surface of Earth.
Okay, sir.
I am done, sir. Done, sir.
So we'll conclude today's class over here. In tomorrow's class, we'll talk. There are some other reasons for the value of variation of G also. So we'll be talking about them, and
Sir,
we'll
for
be
today's
doing Kepler.
tomorrow's weekend test, we will have rotation, no, sir?
What? Yeah, tomorrow's weekend is based on rotation only.
Rotation only, no, sir? Okay.
Yes. If you
But
want, I can
rotation
add
and
on
little.
gravitation also. It's up to you.
Sorry, sir?
Do you want me to give questions on gravitation too?
Sir, we can do that from next week. So I guess it'll be better you
Okay,
have
then
a test on
we'll
rotation.
have it on rotation only.
Yes, sir. Okay, sir.
Okay,
Thank you,
sir.
sir.
Thank
Thank
you,
you.
sir.